Thanks for joining me here. So this talk will be about cross-account role access in AWS environments. But before we go there, just a short introduction. Who am I? I'm Aleksi Kallio. I'm a security consultant at WithSecure. In my daily job, I'm mostly focusing on cloud security and mostly on AWS environments. So here is a quick TLDR of what we are talking about. So AWS IAM is pretty complex. It's complex even in small environments, but it's especially complex when we are dealing with large environments with multiple accounts. IAM role trust relationships can create some interesting attack paths in the AWS environments that could be exploited by attackers. Especially in larger environments, identifying and finding these sort of potential attack paths is, however, quite difficult because IAM is complex. In this talk, I will show you IAM Graph, which is a tool that we built to model this sort of cross-account role access relationships that can help you to find these paths and remove them if they were not needed. Agenda for this talk is like this. We'll start by defining sort of the problem, and there we will also cover the basics of AWS IAM. So even if you're not that familiar with AWS, I will try to cover all the basics that you need to know to understand sort of what the issue here is. Then we will discuss about the cross-account IAM role access, what it is, and how attackers could maybe use it. Then we'll show IAM Graph, what it is, what it does, and in the end we will have conclusions and ideas for future work. Okay, so like I said, to understand this problem, we need to understand the basics of how AWS IAM works. We'll go through the basics. We definitely will not cover everything because it's quite complicated, but we will try to cover everything you need to understand sort of the basics. So first of all, what it is? Well, it's identity and access management in AWS. It's the service that does all the authentication and authorization decisions in the AWS control plane. So if you're trying to do some actions in the AWS account, IAM is the sort of service making the decision that is this identity allowed to do it or not. So if you don't know AWS, it's pretty much like Active Directory for AWS, or AWS's equivalent of Active Directory. It's also pretty complex, and probably it needs to be because it needs to cover all the possible use cases and scenarios you need to want to configure. And because of that, it's pretty hard to do right. And if not all, at least majority of all the security incidents in AWS environments are somehow related to IAM. If the root cause is not IAM, then the IAM usually, or misconfigurations in IAM usually lead to the impact of the incident being bigger than what it would otherwise be. So it's hard to do right, so it's easier to just cut corners and essentially give more permissions to everyone than they would need. Okay, so to understand how AWS IAM works, we start from an account. So account is basically in AWS sort of the basic building block of everything. All the resources you create in AWS, they are always inside an account. So resources means the virtual machines, EC2s, Lambda functions, whatever databases you have, they are contained inside an account. And the IAM users and IAM roles are the user identities, or identities in AWS IAM. So IAM users and IAM roles can be attached with identity-based policies that give them permissions. And when they are given permissions with identity-based policies, it means that they can access the resources in the account. So identity-based policies are like policy documents that define what the user or the identity where this policy is attached to can do within this account. And identity-based policy could look something like this. Here is an identity-based policy called administrator access. And it's essentially a JSON document which defines what actions are allowed against what resources. So this is an admin policy, so it allows all actions against all resources. So when this policy is attached to the IAM role here, it can do anything with any resources in this account where it is. And the important thing here to understand is that the account is like a security boundary. So all the permissions defined in the identity-based policies inside the account are only applicable for the resources inside that account. So for example, here this IAM role has permissions for everything, but it doesn't mean everything in the world. It means everything in the account the role is and this policy is in. Okay, so an account is a security boundary. But of course, this security boundary can be crossed with a thing called role assumption. So role assumption is, well, all of the IAM roles are attached with something called trust policy. And in a trust policy, you can define the principals, meaning users or roles or other things in AWS that are trusted by this role. And when they are trusted by the role, it means that these identities are trusted to assume this role. So, for example, here in the center, the admin role in this account is attached with a trust policy that defines a trusted role in another account as trusted. So this means that this admin role trusts this trusted role to assume it. So if there is this sort of trust relationship, then potentially the trusted role can assume the admin role. But in order to do that, it needs to have permissions in its identity-based policies to assume actually the role. So it needs the permissions. It has like STS assume role, so then it can assume role. And if these two things are correct, so the identity is trusted by the role, and it has the necessary permissions to call this STS assume role API, then it can assume the role. And in practice, when you assume a role, you get access to temporary credentials with the permissions of this role. So this trusted role would get credentials with permissions of the admin role. So essentially, it could move to the account where the admin role is. So if you're not familiar with AWS, it works like a sudo in Linux. So you start from one entity, and then you move to another entity with different permissions. Of course, to make this bit more interesting, also the assumed roles can assume the roles that trust them. So then there is a thing called role chaining, which means that you are assuming roles, and then after that, with the assumed roles, or the credentials of the assumed role, you assume another role, and so forth. You can assume as many roles in chain assume as is like, if there are just roles trusting the role you assume, you can do it indefinitely. So what is the problem here then? While role assumption has like many, between accounts, has many like perfectly valid use cases, it's also something that can be exploited by attackers. So like if an attacker gains in one way or another access to an AWS account, they will most likely try to see if there are any roles trusting that principal they have gained access to, and if they could assume a role in some other account, and this way have a greater impact of their attack. So move laterally between the accounts. So in a big environment, the issue is that what if we have this member account right here? How can we know that what the roles or the IAM principals in this account, what roles they can assume across the whole organization? So if an attacker gains access to this one member account right here, how can we know that they cannot access all of the other accounts in the organization? So like, or to turn it around, if we have some sensitive account in the organization, like the management account over there, how can we know that which are all the identities that can assume roles inside that sensitive account? So, like I said, IAM is pretty complex. This is the diagram showing the evaluation logic behind the decisions made by IAM that whether a user is allowed to do something or not. So, if we have the large environment and we want to find out all the roles that can assume, or all the IAM principles that can assume roles across the whole organization, we should do this evaluation logic basically on all roles and all the identity-based policies and resource-based policies, all of the policies that there are to sort of find out. And you probably understand that if we have environment with hundreds of AWS accounts and thousands of roles and God knows how many policies, it's basically impossible. So there are some open source tools that sort of touch this problem or work with a similar issue. So like cartography, it's not an IAM specific tool. It's more of a tool of mapping different resources in the AWS environment, but it also does some sort of relationships for IAM principles. And Aspects, it's a great tool, but the big problem with it is that it's only working in a single account context. So like it doesn't take into account the role assumptions between accounts at all. So it's useless in the problem which is defined. And PMapper is also like an IAM auditing tool or IAM sort of assessment tool, but it's also not maybe the best if you are working with a very big environment with a lot of accounts. So we found that these available tools didn't really suit our needs, so we built our own tool called IAM Graph. So IAM Graph is a tool to map the sort of effective assume role paths between multiple AWS accounts as a graph. So it works with IAM data, it's a graph, so it's IAM Graph is the name. So before we go into how IAM Graph works, let's talk about IAM Spy, because internally IAM Graph uses IAM Spy to do some IAM evaluation. So IAM Spy is a tool built by Mohit Gupta in our team. It's essentially a SMT solver that gives you answers about AWS IAM. So you can feed the solver with all the policies in the environment, and then you can ask it questions like, can this principal do this action for this resource? Or what are all the give me all the principals who can perform this action to these resources, and then it returns that to you. So essentially, I was showing the IAM evaluation logic, the big diagram. So essentially, it sort of implements that and works and lets you evaluate different things about IAM offline. So there is a link to a great presentation given by Mohit and Nick Jones about this a few years back. So if you're interested, go check that. But yeah, IAM Spy is used by IAM Graph, which is a tool that we built here. So this is how basically on high level how IAM Graph works. So it works offline against the data collected from the target environment. So there is the accounts on the left-hand side. So it works with the output from the AWS CLI command get account authorization details. So in order to use it, you need to first collect that data from all of the accounts that are in your environment that you are interested in. Then it takes the IAM configuration data, parses it, and builds a graph model about the environment to a Neo4j graph database. After this, it uses IAM Spy to analyze the generated graph model to identify the effective assume role paths in the environment. So it creates relationships between the principals who can assume roles, and then you can see what can basically assume what in the environment. The graph model it creates would, in a simple environment, look something like this. Let's not go too much into detail in that, because we have a short demo recorded here where it works in practice. So here I have a machine where there is a Neo4j running as a container. Then I have collected input data, so the IAM data from my target environment. It has 3 accounts, so I have collected the IAM data from all my accounts. And here is, if you're not familiar with AWS, it's just a snippet of what the output of the CLI command get account authorization details looks like. So when we have this collected and Neo4j is running, then we can execute the tool like this. And what it does now, it takes the input data, parses it, and generates a graph model. And after that, it runs the IAM Spy analysis to find the actual paths from the from the model. And after it's done, it's built the model in the database. Then we can use Neo4j has this great browser interface that you can use to query the contents of the database. So with a simple environment like this, we could just, with that kind of query, we can return everything from the database. So it basically returns the whole model. So in the database, it has created nodes for each account that there is in the organization, each IAM role there is in the input data set. And the policies attached to the principals are stored alongside. So there is also nodes for all the IAM users in the environment. And then there is this relationship type in that shows you basically where these principals live in. Then there is another type of relationship which is called trust. And this relationship is created by parsing the trust policies of the IAM roles. And if the IAM role trusts an account or some other principal, then this type of relationship is created to that principal in the graph. So it shows sort of what is trusted by these roles. And the roles can trust accounts or individual users or individual principals. It should be able to handle all of that. So there's an example of a role that trusts a user called CLI user. And after this, it creates a third type of relationship, which is the can assume relationship. And this is the sort of interesting part. This is the relationship which is created based on the analysis with IAM-SPY. So yeah, I'll pause quickly here. So like the trust relationships are created by parsing the trust policies, but after that we query the database and look for all the sort of potential paths that could, or potential principals that could assume a role. And then we ask IAM-SPY that, hey, can this role actually assume this role? And then IAM-SPY does the evaluation and then returns us with yes or no, it can, or no, it can't. And if it can, then we create this can assume relationship to the database. And with a small environment like this, we could just query the whole thing at once like we did there and explore that. But obviously in bigger environments, it's impossible because there can be like hundreds of accounts and thousands of roles and users. So you cannot query the whole database or the whole graph model there at once. So then you need to do something like this we are doing here, that we can do sort of more refined queries of the thing we are interested in. So for example, now we are querying only the can assume relationship because those are the things we are interested in, because these are the effective paths in the environment. And with this demo environment here, we can see that, actually there is a CLI user or user named CLI user, which is in this account, which can assume these 3 roles and end up as an admin role in totally different account. Yeah. Okay, so that's for the demo. So conclusions, IAM Graph is a tool that can automatically map the effective cross-account paths in large AWS environments. We've used it in environments consisting of hundreds of accounts. It works fine. It takes some time to run all of the analysis there, but it works fine. And how it could help you, you could run it in your environment and try to find sort of unnecessary access paths from the organization or trust policies trusting something that they shouldn't be trusting. And then you can try to remove those and obviously limit the attack surface. It's not like a complete IAM audit tool. It doesn't aim to do anything like finding dangerous permissions or privilege escalations that are because of some excessive privileges somewhere. So there are other tools that do that, and this doesn't aim to do that. Some development ideas for this approach and this tool. So first of all, the graph model it generates, it could be enriched with some additional data, for example, about sensitive accounts or admins in the organization or whatever, and then you could do like queries that more useful queries with that additional information and find more interesting access paths. And like I said, at the moment it's not a generic IAM analysis tool. It doesn't do any permission evaluation sort of in order to find privilege escalations or overly privileged principles, but it could easily do that because it already has the data in it, so like it's just a matter of having that sort of automatic analysis. It also doesn't automatically give you sort of any answers. It just builds the graph model and finds the effective paths there, but then it's up to the user to use that to something useful, and so to query the path or query the database and actually find the interesting stuff there. Okay, so if you're interested in this stuff, there is some more info. First of all, we are open sourcing this IAM graph. It's not there yet. The repo is over there, but it's not public yet, but it will be soon, hopefully next week. Then IAM Spy, it's also open source. This is the repo for that. And if you're interested in learning more about the AWS IAM, there are some good resources over there that can help you start it. Okay, with that, we have, I think, a few minutes left. So if there are any questions, I could take now.